Welcome back once again. Mr. Wakefield here in section 4.1 right here at the beginning of chapter 4. And we're looking at what we call inequalities right now. Inequalities are basically just like equations, all right, where you have a mathematical expression on each side. But the difference is that in the middle, instead of having an equal sign, you have one of four different possible things. It could either be greater than, less than, less than or equal to, and greater than or equal to. Okay. This is going to sound a little bit silly, but the way I always like to teach it, just to kind of make it a little bit easier to understand and kind of lighten things up a little bit, is I would like to refer to these things as an alligator mouth. Okay, my first grade teacher referred to these as alligators right here, and why did she refer to it as that? It's because what does an alligator, like any animal, want to eat? They want to eat the bigger amount, right? Okay, and so that's the reason why this is a true statement right here. 8 is bigger than 3 because the alligator mouth is moving towards the 8, isn't he? Okay, the bigger amount. And so, pardon me when you hear me say that, okay, but that's just, again, it's just something to kind of lighten things up and make things easier. So, greater than, less than, greater than or equal to, less than or equal to. Okay, the thing about the greater than or equal to right there, less than or equal to similar, is if I said 4 and 4, this would be a true statement as well, because remember, it says greater than or equal to. That means that if either one of those things is true, either 4 greater than 4 or 4 equal to 4, then this statement is true. It could be either one in order for it to be true. And so this is a true statement here then, because the equal to part is satisfied. 4 and 4 are equal. Okay, but if it had said 4 greater than 4, now that would be false right there, because it only opens up the possibility that 4 has to be greater than in order for this to be true, and clearly it's not. Okay, so that's going to affect our answers a little bit. Okay, those little equal to things, which I call alligator feet. Okay, it looks like the feet underneath the alligator mouth, and alligator feet is a reference to the little equal things there underneath the alligator mouth here. So these two don't have alligator feet, these two do. All right. Anyway, so because inequalities are very similar to equations, the way we solve them, as it turns out, at least in this case, is very similar as well. Okay, now a linear inequality is just like a linear equation that we saw from back in section 1.4, the very first section of our class, all right, where both sides, at least after you clear out the parentheses, both sides are polynomials, and you don't have any visible exponents attached to the variables there. Remember, we talked about that means that it's linear. Well, these problems here are the same. Even after I clear out my parentheses here, okay, you'll have just x's. You won't have x to the second or x to the third. You'll have just x, and it will be a polynomial on both sides. That makes it linear. This is good news, because when you have a linear inequality, the steps that you use to solve it, these same 4 steps right here, you can use those same 4 steps in the current problems with the inequalities, with one major exception, which I'll go over. But other than that, those four steps that I just showed you in 1.4 can still be used. All right. I will get to the exception here in just a moment. Okay. Let me go ahead and go through the problem here, though, first, the first problem. And let's just proceed as we normally would, where the same way that we would solve a linear equation, we'll solve this. Okay, so that means I need to distribute first, like this. Okay. And then what do we do after we distribute in a linear equation? We combine like terms, don't we? Okay. Now, at this point, as you guys now know from linear equations, is that you have what? You have the terms with the variable in it, and the terms that don't have the variable in it. Okay, you need to get them on opposite sides of each other. I'm going to go ahead and move the x's over to the right. You could move them to the left, but I'll move them over to the right. And at the same time, on this step, you're allowed to, as long as it comes out the same way as it would have if you had done these two steps separately, the 8x step and the 8 step here. Okay. But I'm going to move the 8, I'm going to subtract the 8x over, and I'm going to subtract the 8 over here. And I get what? I get negative 5, and I get negative 1x. Okay. Is x by itself yet, which is the goal when you're solving a linear equation, right? No, it's not. You got to divide by negative 1. Let's go ahead and stop right there. Don't do anything else yet. Something's going to happen that's a little bit different here. Let's go back up to the directions up here. It says the steps are the same, but you must also consider the following. If you multiply or divide both sides of an inequality by a negative number, right now we're dividing by a negative, aren't we? If you multiply or divide both sides of an inequality by a negative number, you must switch the direction of the inequality symbol. Okay? So since I'm dividing by negative 1, that means on both sides, and dividing on both sides, I have to take this inequality symbol, which is currently, the alligator is currently biting in this direction, right? And it looks like greater than. It's going to flip around and look like less than now, isn't it? It's supposed to flip around. Why does this happen? Okay, let's talk about that for just a moment. You don't have to write this part down. This is just an explanation to help you understand why. But let me put it on a separate thing here so you can see it. Here we go. Look at these two numbers right here, you guys. This is not an equation or inequality. There's no variables here, but this is just to make a point. We know that negative 2 is greater than negative 4, okay? We know that because it's further to the right on the number line, okay? Anytime a number is further to the right on the number line, it is going to be greater than, okay? Here's the number line right here. There's your 0. There's a negative 2. Negative 1's right there. Negative 4 is over here, right? And there's negative 3. Negative 2 is further to the right. Anyway, what if I divided both of these by negative 2? Just to make a point here. There's no variable, okay? So, but what if I divided by negative 2? Which one's bigger now? The 2 is, right? But that's why I have to flip that thing. Otherwise, it wouldn't be true anymore, would it? So in order to keep it true, when you divide by a negative, you got to flip it. Now, what if I divided by a positive instead? Let's redo it. Let's start over again. This time I'm going to divide by a positive, like that. What two numbers do I get now? I get negative 1 and negative 2, don't I? Which one's bigger? The negative 1, right? Okay. So see how when you divide by a positive, you don't flip it in order to keep it true. But when you divide by a negative, you do flip it in order to keep it true. Okay. So that's exactly what we're going to do. Since I divided by a negative, I'm going to flip it. If I had divided by a positive, I wouldn't. Now I got x by itself, right? Okay. Normally in an equation, when you get x by itself, you're done when you're solving a linear equation, but not here. Look at what it says here after it says to solve. Okay, it says to graph the solution set on a number line and then write the solution set in interval notation. Here's the reason why you got to do all that. When they say, let's say for example, you had an answer that was x equal to 5 instead of x instead of having 5 less than x like this, let's say it was x equal to 5 instead. There's only one number that would be a solution here. Only one number could you plug into this equation that would make it true, and that would be 5. If you plug in 5, it's 5 equal to 5. If you plug in anything else, it's not true. 6 is not equal to 5. 7 is not equal to 5. Okay, only 5 would work. So when it's x equal to 5, that's clearly the answer and the only answer, and that's why we were able to just circle that and move on to the next problem whenever we did an equation. However, when you have an inequality, that's totally different. What are some numbers that make this true? Remember, when you solve something, you're trying to figure out what makes it true. Wouldn't 6 make this true? 5 is less than 6. But wouldn't 7 also make it true if I plugged it into here? What if I plugged 8 into the x? Or how about 9 into the x? Or how about 10 or 11 or so on, so on, so on? Okay, there's a whole bunch of numbers that are going to make this true. The typical inequality problem, you guys, is going to have an infinite number of solutions. Now, that does not mean that you have to write the fancy brackets we saw in 3.1. It also doesn't mean that you should write infinite number of solutions like we did in 3.3. I'm not saying that. This is a completely different kind of problem. What we need to do is, and we did this when we were graphing lines before, is the reason why we graphed lines before was because they had an infinite number of solutions on the line, and so you had to illustrate them in that way. This is very similar to that. Okay, but you do a number line instead of a x-axis and a y-axis. You just do a number line because you only have what? You only have one variable. You don't have two variables like you do in most of those equations that we graph the lines for. Okay, so it's kind of like having just an x-axis. Okay, because you only have one variable. All right, but we're going to illustrate all of the numbers that make this true. So what you do is this. Once you get the x by itself, and don't do this until then because this number is going to change before you get x by itself. All right. But now that x is by itself, you take the number on the other side, which is 5, put that on your number line. I really don't care where you put it because it's the only number that's going to go on there. So that's fine to just put it there. Then here's how the one variable linear inequalities work. We're going to see two variable linear inequalities later in the chapter, but with the one variable linear inequalities, the way it works is like this. Once you put the number on there, all of your answers, you guys, will either be on this side of the number or they'll be on this side of the number. Okay? It's just up to you to figure out which side. And here's how you do that. Okay? If the alligator is eating the variable, that's the easy way to remember it. If the alligator is eating the variable, then it always is on the right side. I'll explain why that's true here in just a second. All right. But go ahead and shade that in. Don't shade anything in on the other side. Remember, it's just on one side where all the answers are going to be. None of them will be on the other side. Okay. Why is this true now? When the alligator is eating the variable, that must mean that the alligator thinks that the variable is bigger. And it's the variable where you plug in numbers that make it true or not. So if the alligator is eating the variable, that means the variable is bigger, which means that the numbers you plug in had better be bigger in order for it to be true. Okay, and when you go to the right, you guys, those are the bigger numbers. The bigger numbers are always on the right. Okay, so bigger numbers on the right, because the alligator is eating the variable where you plug the bigger numbers in. And the alligator would want to eat the variable if you plug bigger numbers into it, wouldn't he? So to make a long story short, whenever the alligator is eating the variable and not the number, if the alligator had been going the other way like this and it was eating the 5, then you would go to the left. I'll show you that on the next problem. It's got something similar to that there. But if the alligator is eating the variable, you always go to the right. Okay, there's one more thing we got to do on the number line. We saw something kind of similar to this, but not completely the same when we were doing domain problems. Notice that, in fact, I'll bring us back to that. Let me show you that real quick here back in the domain problems. It's going to be done a little bit differently here because the shadings are a little bit different. But remember when we had these open circles right here, and then we had round brackets for that? The open circle meant that the 2 and the negative 11 were not solutions, and then we used round brackets. So remember, you guys, round bracket means that that number is not actually in the solution set. It's not shaded. Okay? And you can see why here is because the 2 makes the denominator 0, and so it's not supposed to be in the solution. Okay? Well, open circles are like round brackets then. And so here's my question, you guys. If I plug in 5 right here, I want to see if I'm supposed to put a round bracket right here. We're not going to do an open circle, although you could do that. I'm not going to. It's okay to put an open circle here instead, but usually we use a round bracket. But why is it that we need to put either a round bracket or open circle right here? It's because just like that 2 and the negative 11 I just showed you a minute ago, if I plug in 5 right here, it's not true. 5 is not less than 5. And so you either put an open circle here or a round bracket. The reason why I like to put the round bracket there is because unlike in 2.3 where you couldn't really use round brackets here because it was shaded on both sides of the 2, and so we use an open circle just to make that more clear. But the other reason is in the interval notation we're going to be using brackets anyway, and so it'll just be the same bracket. It makes it easier to follow that way. So what you need to do is, after you put your number on your number line, you figure out which direction the shading goes. Then you put your bracket on there. Anytime on a number line, if you have a shading on one side of a number, but not the other side of the number, you always got to close up that shading with a bracket. It was different in the domain example I just showed you because it was shaded on both sides, not here. Here it's just shaded on one side, so you close it up with a bracket that goes in the same direction as the shading. Okay, I'll show you also when you use a square bracket coming up on the next problem here. Okay, so because 5 is not a solution, use a round bracket. When would it have been a solution? It would have been a solution if that little alligator foot was underneath here, because then it would have been 5 less than or equal to 5. And that would be true because of the equal to part. So here's a nice, easy way to remember this. If the alligator, in fact, let's write it down up here. So when the alligator does not have feet underneath him, this is the nice little short way of remembering it. Like in these two possibilities here, we're going to use a round bracket next to that number. And that's the reason why the 5, because it doesn't have the alligator foot next to it, we use a round bracket for that. But if there had been an alligator foot underneath this alligator that's next to the 5, then you would use a what? Then in that case, if the alligator has a foot underneath it, we use a square bracket. Well, again, we'll see that in the next problem here. Okay, but for now, that's the reason why we're going to have a round bracket there. So you got your shading, you got your bracket. Once you've done that, you're now ready to move on to the interval notation part of the problem. And the way you do the interval notation is very similar to the domain problems again. You just follow the shading from left to right, okay, and then you write it in. We're going to do something very similar here. Okay, where does the shading start this time, though? It doesn't start at negative infinity like it did in those domain problems. It starts at 5. So we're going to start at 5, put your comma, and then where the shading ends is, just like we saw in the domain problems, if it goes all the way to the right, that means it ends at positive infinity. And we learned back in that same set of sections in Chapter 2 that infinity and negative infinity are always going to have round brackets. They're always going to have round brackets, even if the alligator's got feet. Okay, with the infinity and negative infinity, that's always round. It's just that the other numbers, okay, like 5, that's where the alligator determines whether or not 5 will be round or square bracket. Okay, and we already determined that 5 was a round bracket. So that's all you got to do to figure out the bracket for 5 there, is just use the same bracket we had for the 5 up here. It's going to be the same. So remember, for the infinity and negative infinity, it's always round. And then for the other numbers, just look at the number line and it'll tell you the correct bracket to use for that particular number. Okay? And there you go. Let's try that again now, and we'll see some different things here so we can kind of see different situations. Here, there's no brackets to get rid of there. There's no like terms to combine, but we do need to move the x over with the 3x, or you can move the 3x over to the right as well, your choice. If I do that, though, then that means that I also have to move the 10 over with the 2, don't I? Okay, because that's going to make the variables on one side. There's 4x right there. And then it'll put the 2 and the 10 on the other side, and that would be negative 8. Okay. By the way, don't ever flip this inequality unless you multiply or divide by a negative. Okay, if you're subtracting or adding a negative here, like adding negative 10, that doesn't count. It's not when you add and subtract. It's only when you multiply or divide both sides of the inequality by not an equation, but the inequality by a negative. Are we going to have to divide by a negative here? No, we're not. We have to divide by positive 4, right, in order to get the x by itself. And as we mentioned a few minutes ago, when you divide by a positive, the inequality symbol does not flip. The alligator is still going in the same direction, okay? And once you get the x by itself, you guys, what do? You take the number that's on the other side from where the x is, and that's -2. You put it on your number line, and then you ask yourself, what direction does the shading go? Okay, let's go back to the last problem, and I'll give us a good perspective here. If the alligator is eating the variable, you go to the right. Well, notice this time the alligator is not eating the variable, he's eating the -2. Okay, his mouth is going in the -2, going towards the -2, isn't it? Okay, and so that means that he thinks the -2 is bigger, which means he thinks that the x is smaller. He thinks that the x is smaller than -2, which means that the numbers that you plug in to the x had better be smaller than -2 in order for it to be true. Okay, the alligator's not lying here. He's doing what's true here. Okay, so if he's saying that x is smaller, then that means the numbers you plug into x had better be smaller in order for it to be true. Now, where are the solutions going to be if they're smaller than -2? Remember, smaller always means to the left. Just like in the last problem, the bigger numbers meant going to the right. The smaller numbers mean that you go to the left. Okay. All right, so that's how you know. Again, remember on these problems, these one variable linear inequalities, you either shade one side or the other. Okay. Once you do the shading, what do? You do your bracket, because anytime you have a shading on one side but not the other side of a number, you got to put a bracket there. Okay, what's the bracket going to be this time, you guys? Again, what did we just talk about? We said that when the alligator's got feet, we're going to use a square bracket. All right. Talked about this a little bit in chapter 2, but when you use a square bracket, it means that that number is a solution, not just the numbers next to it, but the number itself is as well. Okay. If I plugged -2 into this inequality right here, because there's that equal to thing down there, the alligator foot, that means that this would be true. -2 is less than or equal to itself. All right. And so again, when the alligator's got feet, you use the square bracket for that number that it's next to, the -2. There is a very rare exception that we'll see at the end of chapter 8, where sometimes that whole thing about alligator feet determining round or square brackets, okay, sometimes that's not true, but that's very rare, and it's not until the end of chapter 8. So for right now, okay, the way you determine round and square brackets is by whether or not it's got alligator feet. The only exception to that is when it's infinity or negative infinity, in which case it's always round. Okay, otherwise, for the other numbers, the alligator feet tells you what to do. So what's the interval notation going to be here? Okay, again, interval notation means you start at the left, and wherever the shading is, you go accordingly. So since, like we saw in the domain problems, all right, if it started all the way on the left, if it's shading all the way to the left, that means you start at negative infinity, okay, until it stops. As you see here, it stops at -8. It's a similar thing here, okay, where it starts at negative infinity, you put your comma, and then it stops at -2. The one difference is that it doesn't start up again like it did with the domain problems. It just stops right there, and there's no more shadings. Okay. After you do the two numbers and the comma, what do? You do the brackets. And negative infinity, like I just said, is always going to be round. But -2, it is determined by what's in the graph here, which again is determined by whether or not it's got alligator feet. And so that makes it square. And there you go. All right. This next problem here is going to look very familiar to you eventually. At first, let's just proceed through the problem just like normal, okay, just like the other two problems, and then I'll show you how to handle it. It's going to be kind of an unusual thing. Unusual overall, but it's still something that you've seen before. But anyway, we'll get to that, okay? Let's go ahead and proceed here by doing the normal steps. Distribute out the parentheses like this. And then you combine like terms. And then you move the x terms to one side and the constant terms to the other side. But what happens when I do that? Don't all of the x's cancel? Like that. Okay. And these cancel too. So we get 0 on the left side because everything canceled over there. And over here we get -2. Okay. Now, what happens when variables disappear? Usually, what does that mean? It means it's either going to be no solution, or it's going to be, since this is a one variable problem, we learned back in the very beginning of the class, in the very first section, we learned that when it's just one variable, a one variable equation anyway, we say all real numbers. So it's either going to be no solution or it's going to be all real numbers. What determines that? It's whether or not it's true or false. Okay? So let me ask you, is 0 greater than or equal to -2? Is that true or false? Well, 0 is greater than any negative number that you can think of, and so that's going to be true. So with a one variable inequality, you guys, just like a one variable equation back in section 1.4, if it's true and the variables disappear, it's all real numbers. Let's write that down. All real numbers. By the way, there's some additional direction on that. Not that I didn't already say everything you needed to know, but just so that you can see it written down right here. If the variables eliminate themselves and the statement is true, then it's all real numbers when you have a one variable inequality. If it had been false, it would be no solution. So all that's written down right here. You don't have to write down those additional notes, okay, those additional directions. All right, so that is how you solve a one variable inequality, okay. Please go ahead and turn to the next page. There's two additional problems on the next page. Please try those. They're very similar. And hit the play button and we'll see how it turns out. All right. Let's take a look at number 1 here. Distribute it out first. Proceed with the normal linear equation steps. Just remember that if you divide by a negative, you got to flip the inequality as you're doing that simultaneously. Okay, so now I'm going to move over the x's to the left and the 8 over with the 20. You could have moved the, again, just like we do with equations, you could have gone the other way. You could have put the x's over here and the 20 and the 8 over here. Okay, but I did it like this. Now let's suppose you did do that. Let's suppose that you did put the x's over here. Your answer at this point would then be this. It should look like this. This is perfectly fine, even though it looks different. I'll explain that why here in a second. So this is fine, and so is this. Now, if you did it my way, though, don't you need to divide by -7? And what do you do when you divide by -7? You got to flip the inequality because you divided by a negative. X less than -4. What if you had done it this way? In this case, you would have had to divide by +7, which means you don't flip the inequality, and look at what happens here. Yes, it still looks like a different answer, but it's the same. And let me tell you why it's the same. This is important here. If you have the same variable by itself and you have the same number on the other side of where the variable is, and we do, -4 and -4, as long as the alligator is eating the same thing in both of these statements, then that means that both of the statements are equivalent to each other. They are the same. As long as the alligator is eating the same thing, it doesn't matter that the x is on the opposite side on this answer as it is on this answer. As long as the alligator is eating the same thing, and in both cases, it's not eating the x, it's eating the -4. It's the same thing. Your graph on your number line will come out the same either way, and that's what's important. So let's see how that number line comes out. it's going to go to the left after you put your negative 4 on there. And the reason why that it does is because remember we said that when the alligator is not eating the variable, that means that the variable, in other words, the numbers you plug into the variable, are less than, because the alligator doesn't want to eat the variable. Okay, and less than means to the left. And why did I use a round bracket to close that up right there? We always got to put a bracket there to close up the shading if the shading is on one side of the number but not on the other side of the number. Okay, and we had to use a round bracket to close up that shading because the alligator does not have feet next to the negative 4 here. And so we got our number line completely done with the shading and the bracket. Next thing we have to do is the interval notation, and that means to start out at negative infinity because it goes the shading goes forever to the left. Okay, and then it stops as you go from left to right. It stops at negative 4. Please remember, when you do your interval notation, you guys, you always got to go from left to right. So your interval notation should always have the smaller numbers first and then the bigger numbers after that. Always. Okay, that's just the correct way to write it. Remember, negative infinity is always round. That's why I put a round bracket there. And then negative 4 is just going to be the same bracket as it is in the graph. And you can see I did that there. Okay, so that's number 1. Number 2 is much shorter. Okay, it kind of forces you to divide by a negative just to get that additional practice there. When you divide by negative 4 here to get the x by itself, remember it forces you to flip the inequality symbol the other direction because you divided by a negative. And now you have x greater than negative 4. It looks very similar to the last problem, but the difference is that x is now greater than or equal to the negative 4 instead of being less than negative 4. So we still put negative 4 on the number line, but the difference is that the shading goes to the right this time instead of to the left because the alligator is getting, or the alligator wants to eat the variable. When the alligator wants to eat the variable, that means he is declaring that the variable is bigger than the negative 4, all right? Meaning that the numbers you plug into x have to be greater than negative 4. And that's exactly what I shaded here. When you go to the right, remember that means those are the numbers that are greater than. Why did I use a square bracket to close up that shading right there? Okay, it's because the square bracket is an indication that you have alligator feet. And you can see I do here. Last problem, I didn't have alligator feet. All right, now I do. Square bracket it is for the negative 4. So the interval notation, it starts at negative 4 because that's where the shading starts, and it ends at positive infinity because that's always where it ends when it goes forever to the right. Like you can see, it does go forever to the right. Why do I keep on saying forever? It's because remember the arrow means forever, doesn't it? The arrow in a graph means it goes forever in that direction. So forever to the right, positive infinity. And we always use a round bracket with positive infinity and negative infinity. And then the square bracket is square because this is a square bracket here. Okay, so that is how to solve a one variable linear inequality. Okay, let me know if you have any questions. All right, that's definitely going to be very important to understand this because we're going to do plenty more of these types of things as a part of a bigger set of problems, or a bigger type of problem rather, in section 4.2. So make sure you understand this before you go on. You should always make sure you understand before you go on because math usually builds on top of itself, but it's especially important here. So let me know if you have any questions. Okay, you have a good day and take care.